Okay, so let's get on with the last part of this homework, which is plotting the curve. So before we do that, we actually need to vectorize our function. In other words, we need to make it fit a particular form. So let's call this surface.vectorized jmp.vectorize surface. And the second argument is something called a signature. Okay, and this signature is, in essence, a string that tells JMP what this form should fit. And what it is it should take in two scalars and spit out a vector, a vector. Okay, so go off and do that. And we should then grab a vector and matrix object from this. So let's calculate it. Surface vector, t and theta, right? And I'll know right away you're gonna get a broadcasting error. So this is where we have to change the shape of our vector, of our arrays actually, because time is a one-dimensional array. Check that out. So if we do time, all values in one column and none in the other, this becomes a column vector. So we actually want time to be a column vector so that the shape is compatible and we can broadcast appropriately. Okay? And just because I'm paranoid, I'll do the same thing for theta, but I'll make it a row vector. Okay? So then I can go off and unpack x, y, and z coordinates. It goes S1, right? But lowercase s1, not quite right either. Too many values to unpack because this is a four-dimensional array and it's looking down. It's currently looking down the quote-unquote time axis, and it's seeing too many values to unpack. So we actually take the transpose of it, and now we're all good. So we can go off and plot now. Plotting is a little complicated because we're plotting a surface, right? So we want to go off and plot all of our circles and then connect said circles with lines. So let's create a figure equals make underscore subplots, rows 1, columns equals 1, and we want to designate its specifications. Okay? And this comes in the form of, I don't know what to call this, but it's some rather funny syntax type, and the type should be a surface plot. Okay? So now, again, notice how we need to do this in two for loops because we want to go off and plot all of our circles, right? Plot all of our circles and then connect said circles. So let's go off and do let's plot our circles first. For theta in range, actually for I in range theta dot size. Okay, and we should do fig dot add underscore scatter 3D. Okay, x, y, and z. Okay, so let's go off and look at x. It's a rather two-dimensional array of all of our x values and an axis of time. So we need to be careful here. This actually becomes rather complicated. And we want to only grab the values per each, all the values for a portion of time. Or this is not time, this is theta rather. All the values for a portion of theta. Okay? So let's go off and do that. The dimensionality of this becomes rather complicated and a little confusing. Let's do mode equals lines and then line color white. Okay? What happened? Oh, that's right. This should be y and z. Okay? So we go off and do the same thing, but for time now. Okay? For time. So for I in range t. Okay? And we want to flip this now. We're looking at a different axis, right? So now all values here for a slice of time. All values of y for a slice of time. All values here for a slice of time. Okay. Oh no, what happened? Oops, should be I, not T. I was saying one thing and then doing another thing. So, and to get this to display, we then update the figure. So fig dot update layout height. While we're doing it, let's go ahead and set the height and width to look nice. And let's go ahead and update the what's it called? Default theme. I can't remember what the update layout plotly update layout theme. I never remember the syntax here. Template. Default template. Is it template? Default template equal no. Plotly default template. I never remember what the syntax is. Can I find it here? My goodness. You know, why don't I just do this at the plotly.templates.default. Update plotly. You know, just for the interest of time, I don't care. Let's just make it a light theme. I couldn't care right now. I just want this to be done. It would look nice if it's dark, but I cannot for the life of me remember. I would have to reference notes, and I don't really want to do that on screen. But there you have it. There's our helical thick coil plotted all out using the idea of a rotation matrix. So the concepts we covered today is we start with a Jacobian. Okay, start with the Jacobian. We touched on the Frenius-Serre formulas using a TNB frame to designate a proper rotation that's always perpendicular to the curve. And then we use the idea of the rotation matrix to plot concentric circles along said curve. And now we have a plotted out thick coil.